Hello, YouTubers. Today I'm going to talk to you about a very interesting feature when it comes to ensuring that your ASP.NET Core API is fully covered end to end. In the past, we talked a little bit about unit testing, and we talked about, being able to cover all the edge cases when it comes to your business logic. You want to make sure all the possible inputs, you want to randomize, you want to test behaviors rather than particular values. And there are so many schools of thought when it comes to, writing unit tests. What do you really want to tackle when you want to tackle it? But almost everyone agrees that when it comes to unit testing, you want to be able to do as much coverage as possible to as much possible inputs and outputs possible. So you are very sure that your code is protected. Any changes in your code will result in a test failure, which will result in a discussion about whether that change is needed or not, and what the backwards compatibility, what are the circumstances where we want this code to be adjusted according to whatever changes are being pushed in. But today we're talking about something completely different. We're talking about acceptance tests, end-to-end testing. I want to make sure that my controller talks to my service and my service talks to my broker. And for those of you who are not familiar with these terms, brokers, services, controllers, and models and views, it's just the next step to the MVC pattern. It's a way to break out, the responsibility. When people say single responsibility, this is a way to break out the single responsibilities across multiple different categories of classes based on whether they fall in the business logic area, exposure of data area, whether it's controller and views, or communication with external resources. If you're not familiar with these terms, I really highly recommend you go back to my series of videos, which I'm going to put also in the description for this video, which is the fundamentals of building ASP.NET Core applications. These three videos are very important in order for you to understand the next steps when it comes to acceptance tests. But today, let's talk about the theory. Let's talk a little bit about the theory, and then let's talk about the implementation and what things are supposed to look like. So let's just open up a VS Code here. Here we go. So this is draw.io on VS Code. Let's see if we can hide this part here, and let's start working with what we have. Let's talk about the three different layers of testing that I really want you to understand, and which layer of testing for your ASP.NET Core application are we trying to tackle today. In the unit testing world, when we're validating, we're basically validating three things within one service. Like every service has one of three things that happen to it. There is the validation, and there is the processing, and there's the dependencies. And your unit tests try to make sure that all of these three things are covered, right? So this is dependencies. So a simple scenario would be, you're adding in a student to a system, right? And this student in that system, you want to validate that the input, posted entity or object actually makes sense. And then you want to make sure that you're processing that data correctly. Normally with services that are neighboring brokers, there isn't really much processing going on other than the validation before and after, and then throwing the right exceptions. But there's also the dependency, when you want to validate that you're calling the right dependencies and all that kind of good stuff to ensure that your service methods are doing exactly what they're expected to do. And that's what basically unit test is covering. It basically starts, so if this is your unit test right here, your unit test basically will push an input from here. Let's move that guy like this, and it will validate that that the dependency was called, and it will also validate that the output is in proper format. So it's basically testing the validation, the processing, and the dependency within one service, within one business logic unit within an API. So this entire piece in here, I'm going to send that guy to the back a little bit, is just one block, one small block of the many blocks that constitute a microservice or an API. So this here is what I call a service. All right, so the unit test pushes in some data, the processing happens, validates the dependency, it's in control of the entire platform. But this very pattern is also very, very applicable when it comes to acceptance tests, meaning that if I copy this exact guy, exactly the same guy, and put it down here, you'll see that the same pattern itself applies to the idea of brokers, services, and controllers. So this is back to what we were talking about. So this is here a microservice or microservice or an API microservice. And this microservice in here basically has an exposure of some endpoints. The acceptance test runs end to end, meaning that it tries to, validate, it pushes in some data through the controller. Everything goes through the system, it goes through the dependencies, and then it validates that everything is in good shape. You will notice in here that the acceptance test is testing something completely different than the unit test. The unit test is testing, the acceptance that may be thrown, the validation errors and all that kind of stuff. Acceptance test is only validating that the controllers are talking to the services, are talking to the brokers. So you're calling one endpoint and you're saying, post a student, happy path. You want to focus on the happy path. Don't think about exceptions. Don't think about any edge cases. This is all basically covered by the unit test. The unit test is the one that's actually handling all these edge cases. Someone might ask me, but my controller might have some different scenarios. If your controller have different scenarios, then the entire architecture of your API is completely basically wrong, because you're not supposed to have any logic in your controller. If you see FL statement, if you see switch cases, if you see any flow control, any form of flow control on your controllers or on your brokers, you're basically doing it wrong. All your flow control work should happen in your services, and your controllers and brokers are disposable, detachable components of your system that you can replace at any time. So if my service basically is adding students to a database, my service is completely oblivious to what database it's adding these students at. It could be putting it in Cosmos, could be putting it in, for all I care, it could be writing it to a file on the system. All it knows is that it needs to call a broker, and this broker basically writes that data in whatever storage entity it's communicating with, as long as it satisfies the interface that this service requires for a storage broker to communicate with. That's all that it cares about. But with acceptances, the pattern here is a little bit different. Like, as you're testing things in here into the one service, this one service here becomes this one entity that we're working within here, and we're only validating that the controller is successfully communicating with the service, successfully communicating with the brokers. So how do we do that? This is really cool. Okay, this in theory, someone might say, Hassan, okay, this sounds really good on paper, and so is a lot of things in the software industry. On paper, it sounds great, but when we put that into action, how do we take that concept and apply it as an actual implementation in a modern ASP.NET Core 3.1 application? Let's go ahead and see how do we go about doing that. A while back, um, I had one of my students, working on some of the APIs, and we built a little application, a little API. We called it School M. And School M basically is a very simple API. It basically offers the capability of adding, removing, and retrieving students into a database. It's a very simple, basic operations, yet very thoroughly unit tested and very thoroughly um, up to the standard, the coding standard that I'm trying to promote in all my projects. So if you look at the controller in here for the students, you will notice that we have, if you do control MO, you will notice that we are posting students, getting students, and deleting a student. Just very simple CRUD operations. You will notice that my live unit testing in here is telling me none of these controllers endpoints are basically covered correctly. What are these controllers, and they're not really covered. If I go into my student service, you'll notice all the coverage in here, but my controllers are left out Do we write unit tests for the controllers? Do we write unit tests for the brokers? No. We don't really need to do that because these are detachable, disposable, and they don't really hold any business logic. But what we really want to build is a new project in here. And this project is basically an xUnit project, very simple xUnit project. And this project is going to have the exact same name as the existing project, except it's going to be schoolm.tests.acceptance.tests. All right, so this is an acceptance test project, and its responsibility is to communicate with the API and run the full CRUD operations and then tell me that my API endpoints are working correctly. So the first thing we want to do here, we want to build a broker on this test itself, and this broker is going to be the communicator between my acceptance test project and my actual API. So here's a brokers like this, and inside this guy, I basically want to build a very simple class that I want to call it schoolm API broker.cs. All right, this schoolm API broker test like this, and what I basically want to do here is that I want to be able to have my API broker basically initialize the startup.cs on the existing API project so it can load, like phantom load the API without me actually having to run the project. And that's the little magic of fixtures that I'm gonna show you in a little bit. So right, so I have this schoolm API broker, and let's just go ahead in here and basically write some code. The first thing I want to do in here is that I want to start building some private class members. So here's a read only, and then here is a web application factory, which is something that comes out of the box from ASP.NET Core MVC testing. So find and install. So this is something that's natively supported by the ASP.NET Core bundle of libraries. And inside this guy, I'm going to type in my startup.cs. So now where's this startup.cs is coming from? This guy is basically the exact same guy that comes from schoolm in here. So I'm basically picking up this guy, and I'm using a web application factory to initialize this guy. All right, let's call this guy Web Application Factory. Web Application Factory, and it's a private class member. Private. We really have no interest in exposing this, and this is my Web Application Factory. The second thing I want to do, I want to go here and create an HTTP client. And this HTTP client is something I'm going to use to run my API communications, and I'm going to show you in a second what does that mean. So here's that base client. That's my HTTP client. The last thing is basically initialize or basically declare an interface of a little library an open source library that I created. It's called RESTful Sense. And RESTful Sense basically is a very simple library that, saves you the whole hassle about serializing and deserializing, objects when you're passing them to an API or retrieving them from an API or processing them. All of that stuff, it just abstracts away all of that. All you have to do is it'll be as simple as communicating with a method that's local to your application. I really highly recommend using the library. You don't really have to use it, but if you don't really want to bother a lot with the details about serialization and deserialization and reading the stream and all that kind of stuff, I really highly recommend using that service. So I'm just going to go here and say private read only RESTful API factory client. Now, I need to install this library, so let's just go ahead in here in NuGet packages, and let's find RESTful Sense right here. So here's RESTful Sense. I'm installing it, and RESTful Sense has all the little dependencies. All right, RESTful Sense is developed, is deployed. RESTful since I RESTful API factory client. All right, so here's my guy, and this is API factory client right here. All right, now let's initialize our broker, our API broker. So I'm just going to do a CTOR in here, and very simply, I'm just going to go ahead and say this.WebAPIFactory equals new WebApplicationFactory with startup. So I already initialized this guy. Now I want to go here and just create the client. So here is my base client equal this dot WebApplicationFactory dot create client. And then the last thing is that I want to do the API factory, which is a new RESTful API factory client that takes in that HTTP client as an input parameter. All right, so you could totally work with just this guy, right? But this guy is going to make your life so much easier. It's going to make your life so much easier. All right, so that's basically my broker. It's just something that communicates with that API. I don't have to know endpoints. It already knows all the things that it needs to know. All right, now what are we going to do with all of this? The next step here that we want to do is basically to start building a folder here for the APIs that we want to communicate with. But before I do that, we probably want to do first first we want to get the models, right? So let's put the student model that we want to work with. So here's my models, and inside the models, I want to say students, and inside the students, I want to put in that model for the student model that I worked with, and in the student model, I could just get this guy right here. Now, someone asked me this question before. Someone said to me, Hassan, why don't you just create a library, a DLL, and this DLL will have all your models, and this way you don't have to copy and paste the model from your API to your acceptance tests. The important thing about that is that you actually want your acceptance test to have its own model, so all your API consumers, if you change your model without notifying your API consumers, your acceptance test should tell you that your model change is breaking existing functionality and it's not backwards compatible, and it's going to break all your clients before you actually release that code. You know, someone might say, well, why don't you share a NuGet package with all your models across all your microservice? I say some people would go that route, but it basically breaks the entire idea of being stateless, of having every microservice define what it really needs from a model. I think sharing a library between multiple microservices and multiple clients is creating a single point of failure. I have seen situations where this becomes very, very hazardous. Every client should define its own models. And sometimes you don't really want the entire model. Sometimes you're basically just using OData and you're only extracting maybe the name and the grade of a student. You don't really care about the, submission date, or maybe your model is too big that has 20 different properties in it and only you care about 2. So I really highly recommend to be completely stateless, to be completely non-dependent on any libraries. If REST API communications is the route people are going, so we don't have any hard dependencies or anything, especially that if your consumers don't use the same technologies that you use. So, your consumer could be a Java application or a mobile application written with Swift that's trying to communicate with your C#.NET API, directly. How are you going to NuGet that? So it doesn't make any sense. You probably want to basically separate your acceptances models from your actual models. All right. So we have this guy. We don't have services in here. Instead of services in the acceptance tests, I need to probably move this guy up here in the acceptance test. I created that in the wrong project, and I probably need to move my models in the acceptance test right here. Okay. So right, I have my brokers in here. It's not too bad. Let's delete this guy. We don't need this guy in here, and we don't need these brokers in here. We just need that stuff over there. All right. All right, so let's revert the changes in here real quick. We'll go back to this one. Let's just install the dependencies that we need in here. All right, so I need the web application factory. Here you go. and we need the RESTful sense in here. Here's no get packages. Gonna pick that guy again real quick because I was actually creating my stuff in the wrong project. Here you go. Just a quick fix, and startup have to be coming from, yeah, so you probably want to add the dependency. I was actually kind of surprised, you know, okay, let's add a project as a reference, and the reference project we're going to do is the API. So now this startup.cs should be available, and everything is back to normal, no problem. So I have my student, I have everything in place, it's all good and dandy. All right, great. Now the next step, what do we do next, right? What do we do next? The next thing, we want to test our APIs. Basically, I want to be able to communicate with them with my APIs. But before I do that, I want to basically, under this school M API broker, I want to create a partial class. And this partial class will basically describe the endpoint that I'm communicating with. So in here, it will be school M API broker dot students.cs. See, you will notice this guy in here, school M API broker. I don't think I gave it the exact same name, otherwise it would nest right under it. Let's try this again. Like this, students, like this. I also probably want to change the type of this project into to use 3.1, and this is a, here you go. Here you go. All right, so we have school M API broker dot students, right? Now, this is school M API broker. Are they both under the same namespace? School M test dot brokers, school M acceptance test dot API. We'll probably want to fix that real quick. So both of them are under the same thing. So here you go. I probably need to fix the model as well, all the way up to this point in here, test.models. All right, we have this guy in place. All right, you have the students, and now this guy is complaining because it needs to be a partial class, because there's already another class in this namespace that have the exact same name. So this guy should be partial, and this guy should be partial as well, because now this is just a part of it. All right, now I just need to write these operations. I need to write the operations, the normal CRUD operations that we're gonna use in our tests, you know, to communicate with this student. So what are these CRUD operations? I could just start in here and go and say, first of all, we want to define the relative URL for the student's endpoint. So I could go in here and say students relative URL, which is basically an API / student. Someone might ask me, says, where did you get that from? So it's very simple. If you go back to your controllers, you'll see it right here. So students, that's the controller name, / API, so that's / students. All right. I have that relative URL right here. Let's go ahead and do the first CRUD operation. The first CRUD operations that we could make is basically to post a student to the database. So let's go in here and say value task, and here's a student, and our student is basically the one that comes. You want to make sure that's the one that comes from your acceptance test, and then you want to say post student async. I usually follow the term CRUD operation, so I do the create and then retrieve. That's retrieve by ID and retrieve all, and then modify if there's a modify, and then delete. All right, so this guy takes a student as an input parameter, and this here I could actually single line this, one line this, because I don't need to do much. I just need to call my API factory client and then say post content async and just post the student name. Obviously, if your type is not very clear, you could just go and say, okay, we want to post a student to our API communication in here. So this is post content async. I don't really think we need this guy, but we still need the student URL. So this is student relative URL, comma, and there's the content that I'm passing in. So did I misspell this one? It's like this, students relative URL. Okay, see, this guy here is not necessary because it knows the type, because it's already a strongly typed object model, so you don't really need to. So this is the post, right? So let's go ahead. What else do we need from our broker? I need to do a value task for a student CRUD, so retrieve. So in here I'm going to say get student by ID async, and I'm passing in here a GUID, and that's the student ID. And this is basically another await the API factory client dot get content async, and I'm expecting what I'm returning to be a student. And here is my little relative URL right here, students relative URL, and then I'm going to add students relative URL. I'm going to add a slash. I'm going to pass in the student ID right here, like this. All right, that's still under 120 characters. I think it's still legit. The next thing we want to do is to clean up. So I'm going to do a test where I add a student, retrieve the student to verify that that student exists, and then I'm going to clean up, delete that student completely. So just go ahead in here and say async value to ask student, delete student by ID async, and it also takes student ID. The only difference here is that we can go here and say API factory client dot delete content async like this, and this guy returns a student, and it's basically the exact same URL that we have in here. Let me just copy this guy and throw it right here, and we're done. So we basically built the API operations to communicate with our API endpoints to validate that these endpoints do exist and they are actually functioning as expected. All right, so that's the broker aspect of that test. That's the guy that talks to external APIs. It's using all that good stuff and it's communicating successfully this way. Now let's get to the good stuff. Let's get to the API pieces where we're actually writing API endpoints, writing tests to validate what we're doing. So I'm going to go ahead in here and create a new folder. And I'm going to call this folder APIs. I'm going to call this folder APIs. And in this API folder, I'm basically going to go ahead and write the first one. So here's another folder, and I'm here testing the students. And under the students, I'm basically going to go ahead and say I want to start writing some tests for the students. So here's a new class, and I'm going to call it students API tests.cs. All right. One little trick here that we need to do. At the top of this guy, to connect the broker to the to basically inject the broker into your service in here, all you really have to do is just to go in here and say collection, and in here you're gonna go say the name of, and then in here you're gonna basically say API test collection. What is this API test collection? Normally in your ASP.NET Core application, you have startup.cs and you go and say services at transient, and it basically resolves the types for you and sends that downstream for all your services that consume these particular dependencies. In our case in here, we use something called API test collection. This API test collection is something I'm going to put in, I think it better fits the brokers. So I'm just going to go in here and say here's a little class that we call API test collection. And this guy basically is the instantiator of all these little types that we're working with. The instantiator. It's very simple class. It's very, very important. On top of this guy, we're going to use something called collection definition. And this collection definition will have the name of the API test collection, which is this very same collection in here. And this guy basically extend something called iCollection fixture. And this collection fixture has this API broker that we've created. So this guy basically plays the role of instantiating an API broker for you and injecting that into your unit test. You don't have to worry about reinstantiating it, and at the same time, because there is no startup.cs in your acceptance test, you need that little trick in here to do that little magic for you. So in a collection fixture, we're just gonna instantiate the schoolm API broker right here. That's it. That's all what this class is. It just instantiates, it basically inherits a collection fixture with this schoolm API broker, and then it does all that magic for you. This is the definition part, and in here in our tests is um, the collection usage part, the collection usage part. So let's just go ahead in here and bring in the reference. Here's my reference in here, and let me clean up all the references that I don't need. And let's start writing our first acceptance test, our very first acceptance test. So I'm just going to go ahead and say fact, and then I'm going to go here and just write a straightforward test. But before I forget doing that, we probably want to pick up that instance of our API broker in here. So here's a private read-only, and this is my schoolm API broker. This is my schoolm API broker right here. And in the constructor of this test, we want to basically go and say, instantiate this guy with whatever this fixture is throwing at you, right? So this guy takes schoolm API broker, and this guy is a single liner. We really don't have anything else to instantiate, and this guy will be schoolm API broker equals schoolm API. So it's basically a dependency injection situation, except in here you already instantiated this API broker. We just need to pass it in. All right, so this is our guy, and then let's write a little bit of testing in here. So let's go in here and say public async should post student async. So we're just posting a student, right? But the post itself, this post method itself, what it's basically doing, is that it's already validating the get, and it's already validating the delete, and it's already validating the post for you, because you have to clean up, because this is an actual API communication. So let's say, what's our given in here? What's our when? And what's our then? We break our test into 3 different pieces. Some people say assert, assign, arrange, or assert, something like that. It's the same idea. A place where you are instantiating your system, a place where you are your variables, a place where you are basically running the test, and a place where you are actually validating and cleaning up, right? So let's just go ahead in here and create a student. So it all starts with a student, right? Obviously, because this is behavior driven, we don't want to hard code things. But for the purpose of this test, I'm just going to go in here and use dynamics, which is a very simple. Some people use bogus. I'm currently, with a couple of my friends, are looking into bogus, but for the time being, I'm just going to add dynamics in here, which is basically a library that helps you generate random values for a particular object. I'm installing dynamics in here real quick, and then we're just going to create some random student. Let's go ahead in here. And here we go. And then in here, I'm just going to write this little private method that says create random student. And it basically goes and says new filler. Here's my filler. It takes in a student, and it just creates one for me. Ideally, the breakdown and the organization of the project is something completely different. Like, I don't put everything in one place like that. We use partial classes to branch things out a little bit based on their responsibility. But for the time being, I'm creating a random student. So here's a student, random student, create random student. So in this way, I don't have any control over what I'm creating. It's completely randomized, and I'm pushing it through the API, and I'm just making sure there is no conflict in there in any way, shape, or form. So this is a random student, and then I'm just going to define another variable in here just for the, the readability of the code. I'm just going to say input student, right? So this is my input student, which is the same as the random student. And then the last thing in here, I basically want to say my expected student, which is basically should be the same as my input student. Some people tell me, why do you have to do all that? Why don't you just use random student? And I'm like, I want my variable to express the context that they're in. I'm going to show you what this is in a second. All right, so you created an input and expected. All right, this is great. There is no mocking in here because you're actually running things end to end. So you don't need the little mocking magic in there. You just need to actually just post to the actual method. So in here, that means student, right? Student. And this is your actual student, right? And then you could go in here and say this dot school m API broker dot post student async, which is the piece that we just built, and this is your input student, like this. Obviously, this is an asynchronous method, so we have to await it. So here is your posted student, and then we want to validate. We could use Fluent Assertions for that, which is another library that really doesn't care about the references of your models that you're comparing. So let's use Fluent Assertion and just install this guy. Usually when we're posting, we get a student back. And when we get that student back, we want to validate that this student actually is in the database. And I'm going to tell you, we're going to go a little bit, further in a second. So I'm just writing this acceptance test. And then in here, I'm basically saying actual student should be equivalent to expected student. See? So even though I have the same variable, this is the same variable, this is the same variable, the language here is very different. It's helping you when you're writing something. You say, oh yeah, that's the input student, and this is the expected student. This is the expected student. Now, this is the validation. The last thing you want to do, you want to clean up, right? You want to go and say await this dot API broker dot delete student by ID async, and you want to pick up your actual student dot ID and delete that because you don't want to leave data behind you, especially if you're working against a production environment and all that kind of stuff. So you're just cleaning up. I didn't even run the application yet, but you see all these green marks in here? It's just telling me that it's actually creating a, a student in the database. I will prove it to you. If you run in here, and if you go look at School M database, let me refresh the database a little bit. And this is School M database tables, students. You will notice that some of those were created during the time I have the live unit testing. So it's actually running and adding students. But because I added this delete at the end, now it's actually not letting anything stay in, right? So if I delete all of this and I go and actually run my unit tests, which is right here, and I'm going to just disable this guy for a second. And I'm going to also disable the live unit testing so it doesn't keep adding things in my database and all that. I'm just going to exclude this guy. So now it's not running with live unit testing. And I'm going to disable this guy for a second. And I'm just going to run Control RT. So remember, our database is empty, but as soon as this test is done, it's going to create a student. It's going to validate that this student is actually working through the API. So it's actually going through the API to the service, hitting the database, and coming back. So let's see here for a second. Running the tests. If I refresh this guy, here's a student right here. It's a completely random name. It's a completely random person. I don't know about that. You're going to want to make sure that you're not leaving any trails behind when you're writing your unit test. Otherwise, it's going to be really bad. Now, let's just assume that our post endpoint is lying to us. Like that we're sending an object in, and it's not really giving us back. It's just giving us what we gave it in. It's not really there in the database. Someone might say, well, your delete will blow up. I agree. But you could also combine the get endpoint for that. You could say, I don't really care about what this endpoint is returning. It could be lying to me. And instead, I could go and say student actual student and go ahead and retrieve await this dot schoolm API broker dot get student async, and I'm going to take that input student dot ID to retrieve that student from the database. Let's see if that stuff works. So I'm going to erase this guy here, and then I'm going to do Control RT, and then watch the magic. It's going to run. and it's passing. So basically, it's literally validating that the API endpoint is actually returning the stuff that you're expecting to return. Now, what does that mean? If someone goes into your controller like this at any point in time and says, for the get student, I'm just gonna go in here and say this storage student.id and give it a completely different ID before you return it. You will notice that your acceptance test immediately your acceptance test will start saying, nope, this doesn't work out. Watch the failure in here. There you go. And the failure. Why it's a failure? Because your API has failed. It couldn't actually communicate with the database. It reached to the database, it came back, and then something happened to the data in the middle that was not expected. All right, and it only validates these particular cases. Some people misinterpret acceptance tests and they say, oh, we need to test all business scenarios and all different permutations. That's insanity. That's insanity. That's what unit tests are for. Unit tests are simply just for this purpose of saying, hey, I want to only test all the particular edge cases and scenarios, but your acceptance test is validating that you're actually able to communicate all the way to the database and come back without testing any other edge cases, right? Because you've already done that in your unit test. What your unit test can't validate is that whether you are actually successfully integrated with the controller and the broker, because you mock your brokers, right? You mock your brokers and you don't care about your controllers when you're doing unit tests. But with the acceptance test, you're actually seeing the entire spectrum end to end, right? So that basically covers up this piece. Let's go back to our dashboard, that little board in here. That covers up this communication in here. Basically, the acceptances will push through a controller, then a service and a controller, and run all the way back to your system. There is another layer that I will be talking about in the future, which is basically the top layer to this, this is your entire system, where you are validating that one microservice is communicating with another microservice with a third microservice. And this is what we call integration test. So you can see the pattern here is very similar from one to the other. You have the unit tests, the acceptance tests, but now you're talking about it's like we're zooming out. It's like we're zooming out. And also remember, your acceptance tests always happen after the fact. Like your unit tests happen when you are before you write the code because it's test driven, but your acceptance tests actually happen after you've developed everything and you're running through controllers. Some people say, no, I'm gonna write them first. I said, go do whatever you want. You're an engineer, you have the capacity to critically go through the content that I am presenting in here and make the best decision for yourself. You will see a lot of different opinions in the industry when it comes to naming these things. Some people will be like, no, this is functional test, this is integration test, I think acceptance test is something else. If you go through the literature of Uncle Bob, when he talks about all the different kinds of testing, system test and integration test and unit test and functional test, there is all different schools of thought when it comes to basically knowing and validating what or naming what a particular test is. As long as you're in an agreement with your team and your team is happy with the naming conventions and all agree about what this particular thing is, you should be in a good shape. Before I end this video, I want to thank Shimmy, my friend Shimmy, What's Handler. He is the person that actually educated me on this subject, and we've actually tried to make a couple of videos together just to present this topic, but there was some technical difficulties and echoing and whatnot, and I wanted to get this out to the people as fast as possible. I will also reference him in the description of this video, just so you guys could look and see his contribution in the open source community and his genius really when it comes to exploring new technologies and leveraging existing technologies to produce a better value. That's pretty much it. If you have any questions, comments, or concerns, feel free to drop a comment in the comment section, and I really appreciate that 2,000 subscriptions that people have subscribing to my channel, and I'm looking forward to listening to your opinions and addressing your comments as fast as I can. And don't forget to like and subscribe, and I'll see you in another video. Thank you for watching.